Year-old piece of history has been discovered lurking in the waters of Lake Michigan. An avid fisherman spotted the wreckage of the...
Beneath the calm, glassy surface of Lake Michigan, something strange is hiding. Something massive, ancient, and completely unexplained. Dozens of perfect craters, hundreds of feet wide, lie deep below, arranged in eerie patterns that defy natural explanation.
Well, Jess, a mesmerizing scene is taking place in the North Bay. For the first time in 6 years, the round spillway at Lake Berryessa is active once again.
Are they the scars of forgotten geological forces, evidence of ancient civilizations, or something even stranger? What scientists found in the lake's depths has raised more questions than answers, and it might just rewrite everything we thought we knew about one of America's most iconic lakes. Dive with us into a mystery that's only just beginning to surface. Lake Michigan, one of North America's 5 Great Lakes, has long been admired for its size and natural beauty. But recently, it's drawn attention for something far less expected, an unusual geological discovery that has left scientists puzzled. In 2022, a team of researchers launched a project to map the lakebed of Lake Michigan. The goal was straightforward: document the underwater terrain and locate shipwrecks scattered across the lake's vast floor. It was a routine expedition, expected to yield nothing more than the usual mix of rocky outcrops, sandy patches, and maybe a few remnants of sunken vessels. Instead, what they found was entirely unexpected. As the sonar equipment began relaying data back to the surface, the team noticed strange formations that immediately stood out. These weren't random bumps or the irregular shapes you'd normally associate with natural erosion or sediment movement. These were large, nearly perfect circular depressions in the lakebed, located about 500 feet beneath the surface, right where the water turned dark, murky, and impenetrable to light. According to the sonar readings, each of these circular shapes measured between 300 and 600 feet in diameter. They weren't just shallow dips either. Many of them plunged nearly 40 feet deep, forming symmetrical, crater-like structures. What made the discovery even more baffling was the way these formations were arranged. There weren't just 1 or 2 of them scattered across the floor. There were dozens, lined up in a loose, linear fashion that almost looked deliberate, as if some colossal force had moved across the lakebed, stamping out giant footprints. At that point, the researchers had no idea what these craters were or how they had formed. In August 2024, they returned for a closer look. This time, instead of just relying on sonar, they used a remotely operated vehicle, ROV, equipped with cameras and sensors. As the ROV descended into the dark waters and approached the lake floor, it captured high-definition footage of the mysterious formations. What it revealed confirmed what the sonar had shown. There were around 40 of these massive, rounded holes, all cut into the sediment and bedrock in a way that didn't quite line up with anything previously documented in the Great Lakes region. No one had seen anything like this before, not in Lake Michigan and not in any of the other Great Lakes. Naturally, the discovery sparked a wave of speculation. Scientists and geologists began trying to figure out what could have created these formations. One of the earliest theories put forward was that they might be sinkholes or delines. These are natural depressions or holes that form when the ground beneath the surface collapses, often due to the slow erosion of soluble rock types like limestone. This theory has a logical basis. Much of the land beneath Lake Michigan is made of limestone bedrock, which is known to dissolve when exposed to flowing water over long periods. As water seeps into the rock, it carves out voids and tunnels beneath the surface. Eventually, if the weight of the material above becomes too great and the rock beneath can't support it anymore, the surface layer collapses, resulting in a sinkhole. In theory, this same process could happen underwater, creating the kinds of craters that were found in Lake Michigan. Sinkholes themselves are not rare. They've been known to appear in many parts of the world, sometimes with dramatic consequences. In cities, they can swallow entire cars or even buildings. In more rural areas, they might simply create a large pit in a field. And in lakes, especially ones underlain by limestone, underwater sinkholes aren't out of the question. In fact, similar formations have already been discovered in Lake Huron, another of the Great Lakes, where scientists have documented submerged sinkholes with unique biological ecosystems. But while this theory initially seemed promising, it didn't fully explain the specifics of the Lake Michigan discovery. First, the sheer size of the holes raised questions. Most sinkholes, especially those found in underwater environments, tend to be smaller, or at least irregular in shape. These, however, were massive, some as wide as 600 feet, and had nearly identical circular profiles. They also appeared to be unusually deep relative to their width, which isn't always typical for sinkholes formed by natural collapse. Another problem was their arrangement. Sinkholes usually appear sporadically, based on where voids happen to form under the surface. The formations in Lake Michigan, by contrast, followed a rough, linear pattern, trending generally southward. That suggested some sort of directional force or consistent movement might have been involved in shaping them. It's unusual and quite rare for sinkholes to form in such an ordered layout, especially beneath a large body of water. If these were truly sinkholes, they were unlike any previously observed in a freshwater lake environment. There's also the issue of visibility. If these holes are remnants of some ancient collapse, then they've likely been sitting undisturbed at the bottom of the lake for a very long time. But how could such large geological features remain unnoticed for so many years? Lake Michigan is one of the most heavily studied lakes in the world, with countless research missions, shipwreck surveys, and sonar scans conducted over the years. And yet, it wasn't until 2022 that these formations were spotted. That could suggest they're either relatively recent or that they've been overlooked due to their remote location or the limitations of earlier technology. Still, the idea that these are sinkholes isn't off the table. Some scientists argue that it might be a unique form of sinkhole formation, driven by a combination of local geology, water pressure, and erosion patterns, not yet fully understood. Others have suggested that perhaps there's an entirely new geological process at work, one that hasn't yet been identified or studied. Either way, it's clear that Lake Michigan may still hold geological secrets beneath its surface that scientists are only beginning to uncover. In many ways, this discovery highlights how little we still know about the underwater landscapes of our own freshwater systems. While the oceans have long captured the imagination of explorers and researchers, lakes, especially vast ones like Lake Michigan, often go underexplored. Only a small percentage of the lake floor has been fully mapped in detail, which means there could be many more surprises waiting below. For now, the mystery of the Lake Michigan craters remains unsolved. Scientists continue to study the data collected from sonar scans and ROV footage, hoping to piece together a clearer picture of what might have caused such vast and perfectly shaped depressions. Whether they turn out to be sinkholes, the result of some ancient geological upheaval, or something else entirely, one thing is certain: the bottom of Lake Michigan just got a lot more interesting. While the sinkhole theory offers one possible explanation for the massive craters found beneath Lake Michigan, it doesn't answer every question. That's why scientists have been looking into other possibilities. And one of the most compelling involves something far older and more powerful than sinkholes: glaciers. To understand this theory, it helps to go back in time, tens of thousands of years, to the last ice age. During this period, much of the northern part of the United States and Canada, including what is now the Great Lakes region, was covered by enormous glaciers. These weren't just layers of snow or thick sheets of ice. glaciers are essentially slow-moving rivers of compacted ice, sometimes thousands of feet thick, with an almost imaginable weight. Though they move at only a few inches to a few feet per day, their mass is enough to reshape entire landscapes over long periods of time. As glaciers creep across the land, they act like massive bulldozers, grinding and scraping everything beneath them. Rocks, soil, and even solid bedrock are no match for their pressure. As the ice moves, it picks up debris, scours the terrain, and leaves behind a variety of features such as valleys, ridges, and basins. This process is called glacial erosion, and it's responsible for shaping many of the geographical features we see today in formerly glaciated regions. In fact, the Great Lakes themselves are thought to have formed as a result of glacial activity. The glaciers carved out deep basins in the landscape, and when they melted around 10,000 years ago, those basins filled with meltwater, creating the massive freshwater lakes we know today. Given that history, it's not unreasonable to think that the same forces that shaped the lakes could also have carved out the mysterious craters now found at the bottom of Lake Michigan. This leads to the idea that the craters might be glacial gouges or depressions formed by ancient ice movement. According to this theory, as glaciers moved across the area, they would have scraped out sections of the bedrock unevenly, creating deep pockets or troughs in certain locations. Over time, these gouges could have been preserved beneath layers of sediment and water, eventually becoming the craters discovered by sonar and remotely operated vehicles. Support for this theory comes from the observation that the craters appear to follow a general southward path, as if something was dragging or carving its way across the lakebed. This fits with what we know about glacial movement in the region, as most of the ancient glaciers moved from north to south. The roughly linear arrangement of the craters could reflect the direction of glacial flow, with the holes representing areas where the glacier exerted more pressure or encountered weaker bedrock. However, while the glacial theory is compelling, it isn't without its own set of challenges. One issue is the shape of the craters. When glaciers erode bedrock, they typically leave behind features called chatter marks, crescent-shaped gouges or grooves formed as rocks embedded in the glacier's base scrape along the surface. These marks tend to be irregular and are often more elongated than circular. The Lake Michigan craters, on the other hand, are nearly perfect circles, which is unusual for glacial erosion. This geometric precision raises questions about whether glaciers alone could have formed such uniform structures. Another point to consider is the scale of the craters. While glaciers can and do carve large features into the earth, the size and depth of these particular holes, some up to 600 feet wide and 40 feet deep, are still quite extreme. It's possible that the glaciers encountered areas of particularly soft or fractured rock, which allowed for deeper erosion in certain spots. Variations in the bedrock's hardness could have contributed to the formation of larger depressions, but again, the uniformity remains difficult to explain. Despite these uncertainties, the glacial theory remains a strong contender, especially when paired with the idea that other natural processes may have acted on these features over time. For instance, after the glaciers retreated, meltwater could have pooled in the depressions and altered their shape through erosion or sediment deposition. Alternatively, water currents in the lake could have gradually smoothed the edges of the holes, giving them their clean circular appearance. In some cases, glacial activity has been known to create subglacial lakes, bodies of water that exist underneath glaciers. These can sometimes lead to the formation of kettle holes when the ice melts and the ground above collapses. Kettle holes are typically found in glacial outwash plains and are formed when blocks of ice get buried in sediment, later melting and causing a depression. However, kettle holes are usually shallower and not quite as symmetrical as what was seen in Lake Michigan, so this theory doesn't perfectly align either. Given all this, scientists are beginning to consider that what we're seeing on the lakebed might not be the result of just one geological process, but rather a combination of several acting over a very long period of time. Perhaps the initial depressions were created by glacial movement, and then later modified by water erosion, sedimentation, or even minor collapses in the bedrock. Over time, these forces might have combined to produce the clean, circular craters observed today. There's also the possibility that the sonar and ROV images could be giving a somewhat simplified view of the craters. Underwater imaging, while advanced, still has its limitations, especially at depths where visibility is low and water conditions are unpredictable. It's possible that what appears to be perfect circles on sonar scans might actually be more irregular upon closer physical inspection, and some details might be getting lost in the imaging process. Only a hands-on investigation, perhaps involving underwater drilling or direct sampling, would offer clearer answers. Until then, the mystery remains. What's fascinating is that whether these craters were formed by glaciers, sinkholes, or something entirely different, they represent a significant geological feature that has gone unnoticed for thousands of years. That in itself is a reminder of how much of the natural world is still unexplored, even in places that seem familiar. Lake Michigan, like many of the Great Lakes, is enormous, stretching over 300 miles long and reaching depths of nearly 1,000 feet. Despite being surrounded by major cities and regularly used for shipping, fishing, and recreation, much of its underwater environment remains unmapped and poorly understood. This lack of detailed knowledge leaves room for surprises, and the discovery of these mysterious craters is a prime example. As more exploration missions are planned, including those under large-scale projects like Lakebed 2030, scientists hope to fill in the blanks. The goal is to create high-resolution maps of the entire lake floor using advanced sonar and imaging technology. With more comprehensive data, researchers will be better equipped to determine whether these craters are isolated anomalies or part of a larger pattern across the lakebed. That could, in turn, help reveal not only how they were formed, but also what they might tell us about the region's geological past. The glacial theory, while still under debate, reflects the dynamic nature of Earth's landscape over time. From towering ice sheets to melting waters and shifting sediments, the planet is constantly changing, often in ways we can't immediately see. The Lake Michigan craters might be remnants of one of those slow, powerful changes, now uncovered by modern tools and curiosity-driven science. But until more data is gathered and more of the lake floor is studied, the full story behind these underwater formations will remain an open question. While the formation of the craters in Lake Michigan remains a geological mystery, there's another dimension to the discovery that's just as fascinating. What might be living inside them? As scientists investigated the underwater depressions, it became clear that these weren't just empty pits in the lakebed. They could be home to a range of organisms, specially adapted to the dark, cold, and low-oxygen environment at those depths. In fact, they might serve as unique microhabitats, offering insights into how life can thrive under extreme conditions, and even how life began on Earth in the first place. At depths of 500 feet, light barely penetrates the water. The temperature drops significantly and oxygen levels are often low, especially near the bottom. These kinds of environments are similar in some ways to the deep ocean, where life continues to surprise scientists with its resilience and adaptability. In oceans, hydrothermal vents, openings in the seafloor that release hot, mineral-rich water, support entire ecosystems that don't rely on sunlight for energy. Instead, they're powered by chemical reactions between water and minerals in a process known as chemosynthesis. This has prompted scientists to wonder whether the craters in Lake Michigan, although far less extreme than deep-sea vents, might provide similar low-oxygen environments that host unique forms of life. In other Great Lakes, such as Lake Huron, researchers have found ecosystems that survive in oxygen-poor sinkholes. Microorganisms that live there are specially adapted to those harsh conditions and may resemble some of Earth's earliest life forms. It's a reminder that even in modern times, we're still discovering places on Earth where life can take forms we didn't expect. One of the small creatures known to thrive in the Great Lakes' deeper, colder waters is the opossum shrimp. Despite the name, these aren't true shrimp, but rather tiny crustaceans called Mysis diluviana. They get their nickname from a pouch-like structure on the females' bodies used to carry their young, similar to how marsupials like opossums carry theirs. These creatures are extremely sensitive to light and prefer cold, dark environments. They're often found in the deeper parts of the lakes, and it's very likely they inhabit the areas near or even inside these craters. Then there's the deep-water sculpin, a small bottom-dwelling fish that lives near the lake floor. It prefers cold, oxygen-poor conditions and feeds on tiny organisms living in the sediment. Its flattened body and specialized fins allow it to cling to the lakebed, making it well-suited for life in environments like those within the craters. If these depressions offer a slightly different chemical makeup, perhaps more minerals or a variation in temperature, they could support a slightly different population of sculpins or even entirely different bottom-dwelling species. Another organism of interest is the quagga mussel. These small, freshwater mussels are considered invasive in the Great Lakes, having been introduced through ballast water from ships. Despite their ecological drawbacks, they've adapted remarkably well to deep-water environments. Quagga mussels are filter feeders, meaning they consume tiny particles suspended in the water. They often attach themselves to hard surfaces, including rocks and shipwrecks, and they've been found at depths exceeding 400 feet. The walls and floors of the Lake Michigan craters may provide the kind of hard surface that quagga mussels like, meaning these creatures could be playing a role in whatever ecosystem exists down there. What makes all of this particularly exciting is not just the idea that unusual life forms could be living in these underwater features, but that they could offer us a look into Earth's distant biological past. Billions of years ago, before Earth had much oxygen in its atmosphere, simple life evolved in environments that were rich in chemicals and often quite hostile by today's standards. The early oceans were warm, murky, and filled with hydrothermal activity. Microbes that adapted to those conditions laid the groundwork for all complex life that came after. In that sense, exploring the craters of Lake Michigan is more than just a biological survey. It's a way to study how life can exist in extreme conditions, and by extension, how life might have first taken hold on our planet. Some researchers even suggest that studying these kinds of environments can help us understand what to look for when searching for life on other planets. After all, if microbial life can survive without sunlight, deep in cold, low-oxygen environments, then it's not unreasonable to think similar life forms might exist in places like the subsurface oceans of Europa or Enceladus, two of Jupiter and Saturn's moons. Another benefit of studying these deep lake environments is that they are relatively accessible compared to deep-sea locations. Oceanic hydrothermal vents can be located miles beneath the surface and require complex submersibles to reach. In contrast, Lake Michigan's craters are only around 500 feet down. Deep, but reachable with current underwater robotic technology. This makes them more cost-effective and logistically easier to study, opening up more opportunities for in-depth research. What's also interesting is that these environments may be acting as natural time capsules. Because light doesn't reach that far below the surface, and because the cold water slows down decay, organisms and materials that settle into the craters may stay preserved longer than they would in more active, warmer waters. This could provide scientists with well-preserved biological samples, sediment layers, or even fossil-like remains that reveal what kinds of life have existed there in the past. Of course, it's not just the animals that are of interest. Microbial life is often the first to colonize new environments and can survive in conditions where more complex organisms can't. These microorganisms might include types of bacteria that feed on sulfur, methane, or iron, all of which could be present in trace amounts in lake sediment. These microbes often form mats or biofilms on the lakebed, and under a microscope they can look like branching networks or colonies. Some of these bacterial strains may even be entirely new to science, and understanding them could help develop future medical or industrial applications. In Lake Huron, for instance, scientists have already found purple sulfur bacteria in similar low-oxygen sinkholes. These microbes can carry out photosynthesis without much light and thrive in water that's rich in sulfur compounds. If similar microbes exist in Lake Michigan's craters, they could be key to understanding how life adapted to Earth's changing atmosphere millions of years ago, when oxygen was scarce. How good would it be to respond to evasion of the water's scarcity? For now, most of this remains theoretical. Direct samples have yet to be collected from inside the Lake Michigan craters, but the plans are underway. Future missions involving remotely operated vehicles will likely be equipped not just with cameras, but with tools designed to collect water, sediment, and biological samples. Once scientists are able to bring these back to the surface, they'll have a much better idea of what kind of life is present and how it survives. In the meantime, the discovery itself continues to fuel curiosity. It's a reminder that even in well-studied environments like the Great Lakes, there are still entire ecosystems waiting to be discovered. These environments might not just be interesting on their own. They could help answer much bigger questions about the history of life on Earth and its potential beyond our planet. While the craters at the bottom of Lake Michigan have captured the interest of scientists, they are just one piece of a much larger puzzle. This lake, like others in the Great Lakes system, has long carried a reputation for being mysterious and even eerie. Over the years, there have been stories of strange disappearances, shipwrecks, ghost lights, and odd weather events. It's a place where natural history and folklore often blur, creating a backdrop that makes the recent discovery of underwater craters feel like another chapter in an already compelling narrative. One of the lake's most enduring characteristics is how it seems to guard its secrets well. For a body of water that stretches over 300 miles and borders major cities like Chicago and Milwaukee, Lake Michigan remains surprisingly underexplored. Scientists estimate that only about 15% of the lakebed has been thoroughly mapped and studied in detail. That leaves 85% largely unknown, and within that vast, dark expanse could be many more surprises. Perhaps even more craters, geological formations, or ancient structures that have yet to be discovered. In fact, one of the main reasons the initial 2022 mission to the lakebed was launched was to search for shipwrecks. Over 6,000 ships are believed to have been lost across the Great Lakes, many of them in Lake Michigan. The cold, fresh water of the lake has a preserving effect, meaning that many of these wrecks remain remarkably intact, sitting silently on the lakebed for decades or even centuries. These vessels offer not only archaeological value, but also emotional weight, as they are often connected to stories of lives lost and histories forgotten. But beyond shipwrecks, Lake Michigan has become something of a magnet for mysterious tales. For example, over the decades, there have been multiple reports of boats and aircraft disappearing without a trace in an area roughly stretching between Manitowoc, Wisconsin, and Ludington, Michigan. This region has even earned the nickname the Lake Michigan Triangle, drawing comparisons to the more infamous Bermuda Triangle. While many of these disappearances can likely be attributed to sudden storms, mechanical failures, or human error, the idea of a lake swallowing up objects and leaving no evidence behind continues to feed into the sense of mystery. Adding to that are the strange weather patterns observed over the lake. Sudden fog banks, which can reduce visibility to almost nothing in a matter of minutes, have been known to confuse boaters and pilots. Local fishermen and sailors have reported eerie silences, lights in the sky, and unexplained temperature shifts. While science can explain much of this through atmospheric conditions, water temperature differences, and wind patterns, these phenomena continue to shape the lake's folklore. And then there's one of the most intriguing discoveries to date: an underwater rock formation located near the bottom of Grand Traverse Bay, a bay off the northeastern part of Lake Michigan. Discovered in 2007, the formation immediately drew comparisons to Stonehenge, the prehistoric monument in England. The submerged site consists of a winding line of stones that stretch for more than a mile, with rocks ranging in size from basketballs to small cars. Some scientists believe these rocks may have been arranged by humans thousands of years ago, when the area was still dry land during the last ice age. The most striking element of this underwater site is a large boulder, about 3.5 to 4 feet tall and roughly 5 feet wide. What sets it apart is the carving found on its surface. An image that appears to be of a mastodon, a prehistoric elephant-like creature that went extinct around 11,000 years ago. If the carving is confirmed to be genuine and not a natural crack or shadow, it would suggest that the stone was decorated by people who lived in the area before it was submerged. That would make the formation not only older than Stonehenge, but also a rare example of early art in North America. While there's still debate about whether the so-called Michigan Stonehenge is a naturally occurring arrangement or a genuine human-built structure, its discovery once again highlights how little we know about what lies beneath the lake's surface. It also raises the possibility that other cultural or archaeological sites could be hidden beneath the waves, still waiting to be found. With this in mind, scientists and researchers are gearing up for a more comprehensive effort to explore and understand Lake Michigan. One of the major initiatives currently in development is known as Lakebed 2030. This long-term project aims to produce detailed maps of the entire lakebed using high-resolution sonar and remote sensing technologies. These maps will not only help researchers identify unusual features like the craters or ancient structures, but will also support environmental monitoring, navigation, and preservation efforts. A fully mapped lakebed would allow scientists to monitor changes in the underwater landscape over time, track sediment movement, and assess the impact of invasive species or climate change. It could also help locate and protect historically significant sites, such as shipwrecks or cultural artifacts. By providing a clearer picture of the lake's physical environment, the project could even improve safety for those who use the lake for commercial or recreational purposes. But there's another, more philosophical aspect to all this exploration. The search for understanding beneath Lake Michigan isn't just about gathering data. It's about curiosity, about confronting the unknown. Humans have always been drawn to places that are difficult to reach, whether it's deep ocean trenches, dense jungles, or the surface of distant planets. The lakebed of Lake Michigan is one of those frontiers, hidden in plain sight, yet still largely unexplored. The fact that something as large and unusual as a series of giant craters could go unnoticed for so long speaks to how much more we have to learn, even in familiar settings. The lake is not some distant wilderness. It's bordered by highways, cities, and communities. People swim in it, fish in it, and sail across it every day. And yet, just a few hundred feet below the surface lies an environment that's still cloaked in mystery. For now, the craters remain a fascinating unknown. We don't yet know how they formed, what might be living in them, or how long they've been there. But thanks to modern technology and renewed scientific interest, we may soon have answers. And with every new dive, every sonar scan, and every collected sample, we get closer to understanding not just the craters, but also the story of Lake Michigan itself. In the end, this mystery reminds us that the natural world still holds surprises, even in places we think we know well. Whether it's strange underwater structures, preserved shipwrecks, or ancient carvings, Lake Michigan continues to challenge our assumptions and ignite our curiosity. And that alone makes it a place worth watching, studying, and exploring for years to come.